Hey, hopefully you've finished worksheet 2 and now you're back to check your work. So notice I've got the whole thing filled in here. So take a look on this, check and see that you have things done correctly. Remember, hopefully you were able to find all the valence numbers. Remember, the dot diagrams are literally the number of valence electrons drawn as dots around the symbol. Oxidation numbers are right at the top of the columns on the table. Your ion symbol is literally the symbol of the element with the oxidation number as a superscript. And then the names. Notice, fluorine is a negative, therefore you drop the "ine" and it becomes "ide." Calcium is positive, stays as calcium. Aluminum is positive, stays as aluminum. Phosphorus is negative, so the suffix changes to "ide," but again, we're losing the whole "-us." It's not phosphoride, it's phosphide. Now, most of these are just 2 syllables after you've dropped the suffix to add "ide." Most of them are just 2 syllables. Most. There are some exceptions. And so barium, again, positive, name doesn't change. Iodine, the halogens they all change their name the same way. All of them end in INE, all of the halogens. You got fluorine, you got chlorine, you got iodine, you have bromine. So all of those end in INE, and you literally just drop the INE, put IDE in its place, and that is the name. So this is actually iodide, which is 3 syllables, and I just said that most of them are 2. This is one of the exceptions. It is 3 syllables, iodide. Otherwise, it'd just be iodide, and that would be tragic. So gallium, again, positive, change, or the name doesn't change. Chlorine, another halogen, it's a negative, and instead of chlorine, it's chloride. So hopefully you can check all of that, and you can see that you hopefully did that right. Now, moving on from that is worksheet 3. Now, what I want you to do for this is take a look at worksheet 3, which is posted on Classroom. Take a look at worksheet 3 and try to answer these first few questions here, just on number 1. So pause the video, try to answer the questions that are on number 1, and then come back, and then we'll talk about it. All right, so pause it now, go work on it, then come back, and you can watch the rest of this. Hopefully you're back. So what elements are in the compound? Li2O. What elements are those? Hopefully you see that those are lithium and oxygen. Now it says how many atoms of lithium are in the compound? Well, the subscript 2, that goes with lithium. If there were multiple oxygens, there'd be another subscript. So the subscript always follows the element that it belongs to. Okay, so that means there's 2 lithiums. So there's 2 lithiums in there, 2 Li's. How many atoms of oxygen are in the compound? Oops. 1 oxygen. That's not 10, that's 1 oxygen. Now, it says, does the structure Li2O produce a neutral compound? Justify your answer. How do you even know? So does that form a neutral compound? Well, I would suggest to answer this question, you write down the element or the ion symbols. What's the ion symbol for lithium? The ion symbol for lithium would be Li plus 1. That's the ion symbol. What is the ion symbol for oxygen? That's an O with a -2. So the question is, can this right here produce a neutral compound? Neutral. What do we mean by neutral? Well, we mean the charge is balanced. So we have a +1 and a -2. Can those make a balanced neutral compound? Well, you have to remember, how many lithiums did you say were in this compound? 2, which means there's actually 2 of the +1 lithiums. So now, can these 2 +1s, which would be a total of +2, can that cancel a -2 that you have over here from oxygen. Can a +2 cancel a -2 and make neutral? The answer is yes. Now remember, they got this way. Both these lithiums got +1 because they kicked out or lost an electron. Somebody took an electron from them and they became +1. Oxygen became -2 because remember, it had to gain 2 electrons to satisfy the octet. Remember, all of this plus and minus, all of this oxidation number stuff is because they are trying to either gain electrons for the octet or they need to lose a couple of electrons for the octet, which makes them oppositely charged, which makes them attract. Now the last part here, you're supposed to draw a diagram to represent the electron transfer. Use dot diagrams for this. So dot diagrams. We're using dot diagrams. Now I would use multiple colors if I were you. I would use multiple colors, or you're going to have to use different shapes for the electrons. You'll see what I mean in a minute. So if we have 2 lithiums, I'm going to draw a lithium like this, a single dot. Lithium, lithium, 2 of them, single dot. I am going to use a different color for oxygen because I can. Oxygen is going to be blue, and I have 1, 2, 3, 4, and then 5, and then 6. Now, if you'll notice, oxygen has an empty spot here and here. And by empty spot, I mean a place, 2 places where electrons need to be for oxygen to have a complete octet. It wants those 2 spots full so that its outermost level can be full. Where is it going to get 2 electrons? Possibly from these 2 lithiums right here. So, let me get that out of there. What's going to happen is this, and this is why 2 colors is good. Now, you could make lithium's electrons X's, and then oxygen's electrons dots, and then X's and dots, you can tell whose electrons are whose. I like using multiple colors because I have multiple colors available. If you don't have multiple colors, or like a pencil and a pen, or something that makes them obviously different, then I guess use shapes, squares and circles, or squares and dots, or X's and dots, like something that makes sense to you. So this is what's happening. The oxygen wants those 2 electrons so badly, it can pull them away take them off of the lithium atoms. And so this electron from lithium is going to head over here and park itself in an empty spot. And this one's going to head over here and reside right here. That means they're gone. The 2 outermost electrons that each of these lithiums has, I should say the one that each of them has, it's gone now. Oxygen stole it. That makes lithium +1. That's why it's +1. That's why this one's +1. Oxygen now has both of them. It gained 2 electrons, which makes it -2. This is the transfer, okay? This transfer of electrons from one atom to the other, that is what's going to happen here. Again, some atoms are getting their electrons stolen, some are stealing them. Now, it's clear in the picture that oxygen has a full octet. What's not clear is that lithium has a full octet. Lithium does have a full octet. Now remember, it doesn't have 8, but it has a full first level. If we look back at this other page here, let me get to it. Oh, I'm in the way. So when we look back at this, remember, this is lithium right here, okay? Once this one is gone, once this one is out of the picture, then what is left? Well, it has a full first level. Lithium now has a full first level, which means electron configuration is like helium's. That's a noble gas. That's stable. That's a full outer level. Now, the trouble with the dot diagrams is that you'll never see that. You will never see that lithium has a full outer level because we don't draw the second most outer level. We only draw the outermost. So once the outermost level is empty, the next layer or next level down becomes the outermost and it's full. We have to just remember that, oh yeah, once those are gone, now the new outermost level is full. So I hope that kind of makes sense. What you need to do now is try to answer the questions, again, very similar questions and diagrams for the rest of worksheet 3 for the next time you have class. So hopefully this got you at least started where you kind of understand what's happening here, hopefully. And then we'll see you next time. Hopefully you're all taking care of yourselves if you've not been in school, and hopefully you're keeping up on classroom. So we'll talk to you later.